Hey, welcome back again. So you made it through Guess My Number yesterday, and you're back for some more. And so what we're going to do today is we're going to really hit the fundamentals of the Python language hard. It won't be like an app at the end, like you're just going to kind of learn today, and that's the only thing. So that affects some people differently. They're like, oh, well, at the end of the day, yesterday I had a game I could play, right? And today it's just kind of like learning about Python and kind of like learning some of the fundamental things of code. And it's really kind of a survey day. We won't go deep into anything. We're just going to kind of show you some of the high-level important concepts that are going to come up in coding. So let's go back over to REPL again. So get to REPL however you would like. And what we want to do is we want to create a new REPL. So like here's my old one. Here was Guess My Number. It's still up and good. So depending on where you're at, you need to hit the Create button somewhere. I'm going to use the little menu here on the side because I can easily hit Create here. We're going to continue to work in Python, and we don't need any graphics, so we're just going to click the top one here, the Python replit. And today what we're going to do is we're going to make something called the Python Syntax Guide. And so we're going to put Python Syntax Guide, here's the name. And we're just going to talk about different concepts in Python, and we're just going to write a few lines of code, and then you can use this as a reference for like the rest of your programming life to kind of learn more about Python and Python syntax. So the Python Syntax Guide is what we're going to do today. Also say today is extremely long, so yesterday was really about 15 lines of code, and today is more like 120, right? So it's like a lot bigger. So don't feel like you have to do this whole video in one shot, right? So do maybe like 2 of the things today and then just be done for the day, right? And then pick the others up later. It should be no problem. But I'm going to go ahead and create this REPL for the Python Syntax Guide. And what we're going to be doing is we're going to kind of be doing things right from the beginning. And the first thing I want to do is you can go and type this and then I'll talk about it. So I'll just type Python Syntax Guide. So started off different from yesterday, right? So yesterday, the first thing we did is we wrote Hello World. And the way we did Hello World is we just put print Hello World right on the first line. None of this main nonsense. This time we're taking a more structured approach. And so what's going on here? So def is a special word in Python. It turned blue, right? It's one of these magic built-in words. Def is short for define a function. So we're making a function called main. The syntax when you make a function is you say what arguments it receives. This main receives nothing. And then you do this colon again. We've seen this colon many times now. We saw it in while statements and if statements. And then code that is inside the function is indented. What is a function? I keep saying this word function. A function is a block of code that is known by a name. So there's the name main that refers to it. And if you ever want to run this block of code, you call the function. This line right here is calling the function main. So if you were to run this right now, it would say Python Syntax Guide. Now, an interesting thing that people do with functions all the time is they make a function like that and then they run it and nothing happens. And they're like, what? Look at all my code. I've got all this code right here. What happened? And the answer is making a function just defines that chunk of code. And it's not until you call it that it actually does something. So here I'm calling it and it actually does something. Another goof that people make, just to kind of mention it, is they leave off their parentheses. And so they try to call this function main and they just say main, the word. That doesn't call a function. If you want to call the function, you got to add these opening and closing parentheses. That's how the syntax works. That's just how Python works. Almost every language has functions, and they almost all call functions like this. So this is the Python Syntax Guide. So what we're going to do in the Python Syntax Guide is we're going to have a number of different like sub-functions to teach us things. The first thing we're going to learn about is variables. So what I'm doing here is I'm calling a function variables that doesn't exist yet. If I tried to run my program now, it would say variables, that's not a function. So let's make this function variables. So say def variables. And then I like to just kind of put like some print statements in here. Variables. So variables are something that we used last time. Variables you're used to. I'll just go ahead and make a couple variables here. I'll make X and B. These aren't necessarily great names, X and B, but they're also not really that meaningful. If I were to run it right now, it would say Python syntax guide, and then it would say variables. But you'll notice that the variable X was set to 7, but nothing printed, right? That's because we didn't ever call the command print. So print is actually a function as well. So when you say print, it actually does something. And of course, the thing it does is it takes that value and it displays it in the console. So print is actually the most common function. You've been using functions for a long time, you just didn't think about it. And an interesting thing about print, the function, is it can actually receive multiple parameters. So if you wanted to print out X and B on the same line, it can actually do that. Another thing I wanted to say about variables is variables are also called names. Why would they be called names? So i.e. names. And the reason that they would also be called names is because really what's happening is this 7 is in memory, like it's in your computer somewhere in memory. And really the X, the most appropriate noun for it is not variable. The most appropriate noun is it's a name that points to that spot in memory. So you'll also hear people call them names, especially Python users. So we've got the name X and we've got the name B, and these names refer to spots in memory. Another thing that I'd like for you to know about variables is that variables have a type. Now there's a trick you can use to see what the type is, and you can print it out. You can say type X or type B, and you can see what the types of these variables are. I'm not going to go into every single possible type, but there's some that you should definitely know about. One is integers or ints, so this is an integer. If I were to change it to 7.5, it would change to be a float. Float is another type. And then this thing here is what's called a string. So there's a lot that you do with variables. The function of variables is that it keeps the state of your game or your app or whatever it is you're doing known. So really variables save state. So the state of things is in variables. Great, that's all I really wanted to do about variables. I wanted to keep kind of cruising here, keep everything kind of light. The next thing I wanted to talk about is strings. And I like to start all of them with kind of like a little print statement like this. So I'm just going to copy that one and call it strings. Now, if you're paying attention, if you run it now, what's going to happen? It didn't say strings at all. It didn't say strings at all. I put it here. I see it. I see it typed here. I've got 2 spaces, just like you said, Dr. Fisher. It's in a function that is not being called, right? And so what I want to do is in main, I want to also call this function strings. And so now you can see that I've got variables, and it prints the stuff about variables, and then I've got stuff about strings. Now, so far, it hasn't gotten very long over here, so there's no problem just running them all. We could keep talking about strings, it'd be fine. But I'm going to do this. I'm going to get in the habit of commenting out the old one. So comments are the hash, so I just typed a hash and then a space. By the way, you could also do command / and you can just like quickly type that if you wanted. And so if I run it now, my main function only calls the strings function. And so now it just says strings. And I like that trick because it's going to keep our output over here much cleaner, because we're eventually going to have a whole bunch of these things, right? So let's learn about strings. So let's make strings a couple different ways just to see what our different values are. So this is my first string. Let's just call it double quotes. And we'll print out string 1. So this is what we've been doing most with strings. You can also use single quotes. So I'll just go ahead and change these double quotes to singles. Single quotes. If I can get my, my computer to agree with me here, and I'll call it string 2. Again, I type fast. Just pause the video as you needed. There's no reason for me to type slow when you can just pause the video. What's the difference between double quotes and single quotes? Really, there's not much difference. The only real difference is that inside double quotes, you could put something like the word don't, whereas down here, you wouldn't be able to do it, right? So you wouldn't be able to type an apostrophe here because it wouldn't know the difference between the outside and the inside. So about the only real difference is that Inside double quotes, you can put single quotes. I guess you could put double quotes inside of a single quote technically, but I don't really know why you'd want to. I guess maybe you could make a quote, yeah. But people get annoyed by that, by the way, and they get annoyed with this single quotes and double quotes. And so they came up with this alternative version called triple quotes. Triple quotes. And triple quotes can be triples of doubles or triples of singles, it doesn't matter. But the nice thing about this is that you can include, whatever you want in it, so long as it's not a double or a single quote. Oh, I didn't print it, so I didn't see that yet. Print str3. Also with triple quotes, you can do crazy things. So you can, I'm going to get rid of these things. You can have multiple lines. And so if I ran it now, you can see that triple quotes can have multiple lines. And the idea of triple quotes is that you can, the concept is you can put whatever you want in there, right? You can have blank lines. It doesn't matter. You can just do it, right, with triple quotes. And again, that could also be 3 singles. That would work just the same. The other type that we saw yesterday as well is F strings. So this is a formatted string. And the neat thing about formatted strings is you can put things inside of them. So let's say we did like 10 plus 35. It's so annoying when it automatically types a quote for me. I get annoyed by it all the time, but that's fine. All right, so let me go ahead and type it, and then you take a look at it. So formatted strings are really handy because you can actually put variables in here. If you have variables in here, you can do operations in there. You can kind of do whatever you want. So there's 10 divided by 35. It's going to print with a bunch of decimals. And so formatted print strings are really handy, and the only difference between them is the single letter F in front of it. I love formatted print strings. I use them all the time. By the way, you can use singles on this as well instead of doubles, whichever you prefer. All right, I think that's all I wanted to do with strings. The next thing I want to do, and you can see how these are kind of like short little pop topics, is loops. So let's go ahead and make a function called loops. Being a very lazy individual, I'm going to copy the first 2 lines of strings and paste it down here, and I'm going to change it to loops. And then I'm going to change it to loops. And you can see that I'm keeping all my old code up here, but I'm just kind of putting it at the bottom just so you can focus on just the new stuff. So if I were to run it right now, it doesn't print out any of my old stuff. My old stuff is still there. If I wanted to, I could bring it all in and I could print everything, right? That'd be fine. It's just I want to try to keep it a little bit under control, and so I'm going to talk about loops. So what is a loop? So there's 2 different types of loops. One is called a definite loop. So let's go ahead and type this, and we'll just go and see what it does. So this is the Python syntax for making a loop that goes 5 times. The way you read it is you say for, and then you can make up any variable name here you want. I'm using k. You could have it be I or index or whatever you want. You're making a variable, right? I'm making a name. And then it's going to loop over range 5. What does range 5 do? It makes an iterable that has 5 items in it. And those 5 items are sequential and they count. Now, if you're new to programming, you might think that what's going to print here is the numbers 1, 2, 3, 4, and 5, because that would be logical, right? So it'd print 1, 2, 3, 4, 5. Interestingly, in programming, it doesn't print 1, 2, 3, 4, 5. It prints 0, 1, 2, 3, 4. Now, it did not print the 5. It just printed 0, 1, 2, 3, 4. That's because in programming, you start with 0. Period, end of story. You'll see this in list. You'll see this in all sorts of environments, but 0 comes first. And it doesn't print the 5 just because it's only going to print 5 things total. And if it starts at 0 and it prints 5 things total, you get 0, 1, 2, 3, 4. And that's just how it works, right? Lots of things that you can do with loops. One fun thing to do with loops is to make accumulators. So let's say we had a total and we wanted to add up, all the numbers from 1 to 100. I'm going to do this wrong first. And I'm going to say total equals total plus k. And then I'm going to print out, I'll use a formatted print string, the numbers 1 to 100 add up to and then I'm going to put my total in here. So a very common thing that you do with loops is you make accumulators. An accumulator works like this. You've got a variable which has like an initial value. Here it's a total, which is 0. You go over some range. You accumulate the values. That's why it's called an accumulator pattern. And then after the loop, you print it out here. You do have to be careful about things. So first off, there's a slight error in this. This is actually the numbers 0 to 99 added up. We're going to fix that in a minute. Other things that people do wrong is they accidentally put the print statement inside of here. What happens if I do that? Yeah, it's going to be a disaster. It's going to print every time through this loop. And so if I run it now, we're going to get 100 print statements, right? So did not mean to do that. Put it back, run it again. How do we fix this little bug? How do we go from 1 to 100? One easy way to do it is just to say 101. That's one way to do it. That would actually add up the numbers from 0 to 100. Another trick you can do with the range statement is you can start it at some value. So range, start at number 1, and then go up to 101, but it doesn't include the last one, so that would actually work as well. If you're really good at mental math, you could figure out what this is. So 1 and 100, the average number is 50.5. If the average number is 50.5 and you have 100 of them, then you've got to multiply 50.5 times 100. I know this math is getting much for some people. And the answer should be 5,050. So if I run this now and it all works, the answer should be 5,050. Cool. So definite loops, very powerful. You use a definite loop at a time when you know exactly what the range is going to be. There's other ways you can use loops too. We'll definitely talk about that later, but we're going to have to learn about sequences before we do that. The other type of loop that I want to tell you about is what's called an indefinite loop. So we saw indefinite loops yesterday with Guess My Number. Typically the way you do an indefinite loop is, I'll tell you what, let's just make another variable. We'll start it at 0. We'll say x is equal to x plus 1. And then if x is greater than 5, break out of the loop. And then after the loop, we'll print out, we'll just print out x, right? Let's keep it simple. So this loop says while true. This is the most common way to make indefinite loops. You can put some condition in here, but typically you just say true. And then some condition in the loop lets you break out of it. And this turns out to be a very useful pattern. And if you were to print this out each time, you would see that it actually prints out 1, 2, 3, 4, 5, 6, and then it prints 6 twice just because it printed the 6 here, and then it broke out, and then it printed the 6 down there. So indefinite loops become very powerful when you don't know how many times it's going to run. This is kind of a terrible example because we could tell mathematically how many times it's going to run. And so this one could have been a definite loop, but I didn't want to make an input statement. I guess if I'd wanted, I could have said input, give me a number. And then if x is equal to 0, we could break out of the loop, right? So this would be another example of an indefinite loop. So if I give it these numbers, it just keeps asking me. And then if I give it 0, then hopefully it breaks out of the loop. It didn't work. It didn't work because this gives you a string. I forgot. Let me put this in an int. You can tell what I practiced and what I didn't practice. So give me a number. I'm going to give it these numbers. And then as soon as I give it a 0, it exits out, right? So this is another type of indefinite loop that I wanted to show you about. You go to loops. You got your for loops. You got your while loops. Those are the two main types of loops. Let's talk about more stuff. We're cooking with gas now. After loops, let's talk about sequences. And so I'm going to make a function called sequences. And I'm going to make a print statement in here. 1, 2, 3, sequences. So sequences are used in a lot of languages. Some languages call sequences arrays. Maybe you've heard the term array before. Some languages call them list. There's different words that people use. Let's go ahead and make a sequence. The type of sequence we're going to make is technically a list. And we'll go and print it out here. And so what is a sequence? I should do this where I've got a whiteboard available. Maybe I'll switch over here in a little bit to where I've got a whiteboard behind me. But a sequence is something that has a name. So it's still got my list as a name here. But what you can do with a sequence is you can easily refer to each item in the list. So let's say I wanted to grab item 1 in the list and print it out. So it has multiple values in there. But you can access them individually. Question, what's this going to print? Which one is item 1? Who says 4? You're wrong. 5 is number 1. That's because everything in coding starts with 0. So item 0 would be the 4, and then item 1 would be the 5. And then, of course, item 2 is the 6, and item 3 is the 7. Lists are super fun. There's lots of things you can do with list. You can add more values. So maybe we'll append the value 100, and then we'll print out my list. It's one of these things where it turns out to be way more powerful than you would guess. You're like, well, why are lists so important? And it just comes up over and over again where you can do really cool things with list. Other fun things you can do with list is you can use list with loops. And you can say, for my value in my list, and I'll just go ahead and print out, print out value plus 5. And what you can do is you can easily loop over a list. Notice the syntax here is a little different. Before we said like 4K in range, here we're saying for value in my list. And it does away with the need for indices, which is cool. It just gives you the values that are in this thing. And so it's got the values 4, which 4 plus 5 is 9, and then the 5 became that, and then that became that, and that became that. Other things you can do, which are fun with loops, is you can modify things. Maybe that's going to get me in trouble if I do that. All right, I'll stop there. I was going to what the heck, I'll modify things. You could also use the other type of loop. You could say 4K in range len of my list. I should have probably shown you that len is how you can get the length of the list. And what you can do here is you can print out the values. So you can say like my list bracket K. I'm going to comment out this one just so there's less code out there. So you can see that this is just printing out the list. Other fun things you can do with this style is you can modify the list as you want. So let's say that each one is whatever it was before plus 100, and then we print out my list. And so now all of a sudden I've changed everything in the list. So it's kind of fun. You can change values to your heart's content. So if I wanted to, I could say like my list bracket 0 is equal to 9999999. And you can read the values back. You can append values on. There's a lot of cool things you can do with list. Another type of list that you might see some is called a tuple. I'm not going to go into this one much. I'm just going to say my tuple. A tuple is another type of sequence. The only difference is that you can't modify a tuple. So if I were to say my tuple location 2 is equal to 99999, it would yell at me. So it's a sequence, just like a list is a sequence. The only difference is you're not allowed to modify it. If you try to modify it, it'll yell at you. It'll say, tuple object does not support item assignment. So I just kind of wanted to tell you about tuples, but not in much great detail. So this is a crash. All right, so now you know a little bit more about sequences. You'll see sequences when you code all the time. And so you can see what we're kind of doing here. We're just trying to give you a survey of the Python language and kind of make a syntax guide. And it's just exposure without going into great depth about variables, strings, loops, sequences. And next up is functions. This will be fun. So we're going to call functions. Now, we've actually been using functions a lot, right? But every single one of these functions receives no parameters, and it doesn't return anything either. We're going to make a function which does stuff. We're going to make a function which takes three numbers and gives you a result. This, by the way, is called test-driven development, where you make a couple tests. And so the function that we're going to make, it's going to do something arbitrary. Let's, I don't know, let's make it add the first two numbers and then divide by the third one, right? And then print the result. And so this function, which is called functions, which is kind of a terrible name, is going to receive three things and return one thing back. So how is that function going to look different than these other functions? Let's go ahead and write it, and then we'll just take a look. So functions, so it's going to need to receive three things. So this area here, which we've always left blank before, can receive arguments, is what they're called. I'm going to go ahead and print out what I've always done, something that kind of identifies this section. And then what we want to do in here is we want to see what these values are, so we can print out A, B, and C. And then we want to return A plus B divided by C. And so these three things that are passed in become A, B, and C. And then it's going to return or give us back a value. So this one's going to be 3 plus 2 divided by 1, which should be 5. It's going to actually return 5.0, and we're going to print that there. And then 30 plus 9, that's 39. 39 divided by 3 should be 13, and 13.0 is what it's going to actually say. Let's run it, and then we'll kind of keep talking about it. So it looks like it ran twice. It ran with the 3, 2, 1, and then it ran a second time like this. Now, the most important thing about functions is getting your brain around what the computer does. So here's what the computer does. So it called main. Main ran to right here, and then main hit this other function. And really what happens is it's like it halts execution in this main area, and it goes and runs that function, which is called functions. And then it does that thing all the way through, and then when it's done, it returns control back to main. So whenever it hit this spot right here, it actually kind of jumped up here, printed the word functions, you can see that up there, printed my ABC, you can see that right there, and then it returned the value 5.0 in this case. That return value popped down here, and so it's as if we were to write result equals 5.0. It's kind of like that's what happened. And then it printed that result, so this print statement came from main. Those two came from functions. Then it does it again. It calls functions, and it comes up here and it prints the word functions. That's that one. Prints the A, B, and C, which is 39 and 3, and then it returns the 13.0 to right here. We blew away the value of result with this new result, and then we printed the 13. Functions turn out to be super, super useful. You can use functions to organize your code. You can use functions to like call code over and over again. All kinds of cool things you can do with functions. Let's do more stuff. So comment out all of those. I like to use the control / trick. Next up, we're going to learn about imports. So we're going to make a def for imports here. And we'll print out the word imports. Run it and make sure everything is good to go. Imports. What are imports? Imports we used in Guess My Number, so you already saw imports. We imported the random module. But imports let you bring in other people's code. Typically when you do an import, you do it at the top of the file. So I'm going to go ahead and come up to the very top of my file. Let's go ahead and import that random thing again. Import random. So random is a module that somebody else wrote. So they wrote this module, and it's got a bunch of functions in it, which are super fun. And the way we use this is, well, let's just go ahead and print it out. We say random, the module, dot, and then we see what it can do. Usually it's more helpful than this. I'll tell you what, maybe I'll do it as a variable. Random dot, there we go. you can tell if your IDE is good what all functions are in this thing, right? And there's a bunch of them, right? So you can go through here and you can find a bunch of different things. The one that I'm going to use, let's use just plain old random, the function, and we'll print it. And what random, the function, does is it gives you a value between 0 and 1 that's just kind of randomly generated, which is kind of cool. It's got other functions inside of it. It's got one called rand_int, which we saw last time. So if you wanted a number between 1 and 100, it would do that. Oh, sorry, rand, I got too many letters in there. Rand_int. When you're using somebody else's code, it's probably good to like go learn about it. So in this case, I would probably say like Python module random. And I would just go learn about random. And you can see like there's a ton of different functions in here. There's random range, there's random bits, there's shuffle. If you've got a list, it can shuffle it. There's lots of different things it can do. Let's challenge you to do something. So this is your challenge. There is a module called math. Inside the math module, there are functions for sine and cosine. And what I want you to do is I want you to tell me what is the cosine of 2. So how would you write that? So go ahead and make a variable. We'll just call it ANS. And see if you can search the internet. You might need to search about the Python math module. You might also just be able to guess. But see if you can print out for me what the cosine of 2 is. So pause the video and just see if you can figure out how to do it. I will do it too, right? So the first thing you need to do, if we're going to use this math module, I didn't say this, but maybe you picked it out, we're going to need to import something. And so we're going to actually import math. It's kind of fun, you're importing math. And so math is a module that has different functions in it. And math has many different functions in it. If you start typing it here, you can see that there's cosine, there's hyperbolic cosine, there's arc cosine, all kinds of things. The one we want is just called cos. I think I may have given that away right there, that the cosine function is called cos. And so if we wanted the cosine of 2, we could figure out what the cosine of 2 is. It's kind of a crazy number. What if instead of 2, see if you can do the cosine of pi. By the way, in radians, a full circle is 2 pi, so pi would be like all the way back. It should hopefully be -1 if you get it right. So see if you can figure out what the cosine of pi is. How would you do that? How would you figure out what pi is? Well, you could just type in 3.14, right? And so the cosine of 3.14, that's almost -1. That's almost right. If you wanted to do it perfect, though, these modules include variables all the time, too. And sure enough, math knows what pi is, which is cool. So if I wanted the cosine of pi, it should be exactly -1, which is kind of neat. All right, imports, crazy useful. Because you can use other people's code, and when you use other people's code, you can make your code a lot better without writing everything from scratch. All right, we're doing good. We've only got one thing left. You're like, hey, we've only got one thing left. We're almost done. Sweet. The last thing is huge. All right, so the last thing I want to tell you about is an advanced topic. It is the topic classes. What is a class? This is a class, right? We're in a class. I take classes at school. I hate classes. No, you love classes. Classes, let's go ahead and make a little stub for it. Classes are a very important concept in programming. And so what classes do, and they're kind of advanced, right, is classes allow object-oriented programming. Most languages these days, like C was a language that was made like in the 70s. It's not object-oriented. It's got functions, but no objects. Most languages these days, starting with like Java, like back in 75, have started using object-oriented programming. Object-oriented programming is a concept where you take a code, so you take code that you know, and you put it inside of like a factory, and that factory is called a class. I think I'm going to need a whiteboard. Hold on, I got to switch over to a... All right, I got a little space where I can work here. So a class is like a factory. So imagine that you've got a factory here, It's got smokestacks because it's an old school factory. And this factory makes stuff. So they've got an assembly line and things roll out on the assembly line. And this particular factory makes robots. I love robots. I teach with robots all the time. So this factory makes robots. And it makes these little robots with antennas on their head. And every time you place an order for a robot, you get another robot. And so that's what a class is. So this is the class. And now these robots, they've got names too. They're called instances of the class. An instance of the class is here. These robots are all just a little bit different. And they're a little bit different because they've got little changes in them. And so like maybe this one has a red shirt. Maybe this one has a green shirt. Maybe this one's got another arm down here, right? And so the instances can all be different. And they have things that they know. So objects, they know stuff. So they know like what their shirt is or things like that. They also know things that I tell them. I say, hey, your name is Dave. And for that point on, he knows his name is Dave. Maybe I could change it and say, oh, your name's not Dave, your name's Bob, right? But they know stuff, which is important. They can also do stuff. And so I say, hey, robot, kick the soccer ball, right? And so that's something a robot can do. He can kick the soccer ball. It's something he can do. So they know stuff and they can do stuff. And classes become really useful when you write code and object-oriented programming. So we're going to make a class together. We're not going to make a robot class. We're going to make a class called point. And so just above the function, which is called classes, I'm going to make a class called point. Now the only problem that classes have is people understand the concept of like, all right, this is a factory. This is going to make point objects. The thing that's hard is the syntax. So just bear with me on the syntax. So type this, type def space. Notice how this def is inside of the class. Functions inside of a class are called methods. They got a different name. This one is a very special one. This one is, it's actually so special that my IDE wanted to type it for me. I started typing def space. I started typing underscore, underscore, INI. And that's as far as I got before it wants to autocomplete. I'm going to let it type the rest for me. That'd be great. Oh, it didn't type it for me. This is the constructor. So, crazy method name. Underscore, underscore, INT, underscore, underscore, parenthesis self, parenthesis colon. You lost me, Dr. Fisher. You're killing me. This is the special name of the constructor. Let's see it in action some. So let's make this point. And when I make a point, I can place an order with the factory. Now a point, as we know, probably needs like an X and a Y, right? So this is kind of like a point in space here. So it's going to really need like an X and Y value. So let's say this one's at 2, 3. So when I place an order with the factory, I want to tell it, hey, put this point at location 2, 3. And what we have to do is in the constructor, this is like the order sheet. This is like where they place their order. They're going to pass in an X and a Y. And then what I'm going to do in this factory is I'm going to save it off. Type this and then I'll talk about it. So I am placing an order for a point. Let's go ahead and place an order for another point. We'll say, hey, I want point 1, it's there, and then point 2, I want you to be at 77.99, and then I want to print out these things. I'll just go ahead and print it out. Point 1's X, point 1's Y. Yeah, you're going to have to pause the video. So what am I doing here? Oops, I left out a comma. What I'm doing here is a lot of complex code, right? I am creating a point called point 1. It's got the name point 1. I'm placing an order with the point factory. I'm saying, hey, give me a point. I want it at 2, 3. And so at the point where I call this, it calls the constructor, and it's going to say the words, this is the constructor. And what it's going to do is it's going to take that 2, which is currently the value of X, and it's going to save it off. It's going to save it off to something it knows forever. And this is what's called an instance variable. I'm not sure where the best place to put this is, but I've got this point class, and the point class has stuff it knows, and this is a UML diagram, so this is my point class. It knows its X and it knows its Y, and then it has stuff it can do. So we're going to give this class things it can do. So I can run it right now, and it says this is the constructor, this is the constructor, and then it points out 2, 3, and then 7799. So it has stuff it knows, and by the way, I can change what it knows. I could say like 0.1, you're X. No, I meant to say you were -10, right? And then if I print it all out again, you can easily change these things. And notice how it created 2 points for me. So it rolled down the line. These are robots, I know. But it rolled down the line and it made point number 1 for me, and it made point number 2 for me. And in my code here on line 92, I actually changed point 1. You'll notice that that didn't affect point 2 at all, right? Because I changed his X value. Let's go ahead and give them something they can do. Let's go ahead and have them be able to move. So if they have things they can do, they can move. That is more functions inside of the class. So here's what I'm going to do. I'm going to get to my indentations to the right spot. So I need to be inside the class, which is 2 lines, and I'm going to make a function called move. Go ahead and type it with me, and then I'll talk more about it. And what I'm going to do is I'm going to move the X value by some delta X amount, dx for short, and I'm going to change the Y value by some dy amount. And this, by the way, is a method. So I'm going to print, this is a method. And you have typically one constructor. You can't have multiple. We won't get into that. But you typically have a lot of methods, right? And so this is just one method, which is called move. How do you call a method? So I'm going to say, oh, interestingly, you call a method on an object. So if I were to say point 2 move, and I were to move him by, I don't know, 1,000 and 9,000, I'm going to move him a lot. And then I was going to print things out. What I'm doing here is I am taking the second point, point 2, and I'm telling him to do something. So instead of telling him to kick a soccer ball, I'm telling him to move, because that's what points can do. They can move. And I'm telling him to move by 1,000 in the X, 9,000 in the Y. At the moment I call this, my code jumps up here. And this is sneaky. This is super sneaky. I love how sneaky this is. It looks like there's 3 things that are passed in. Self, dx, and dy. Well, the self is actually on the left-hand side of the dot. Sneaky, sneaky. And so we've got self, dx, and dy. And so self is how you refer to the object when you're back inside the factory. So if you're inside the factory, you refer to it as self, because you're inside the factory. And if you're outside of the factory, you refer to it by its name. So outside the factory refers to its name out here. You won't get all of these concepts now, but I wanted to kind of introduce you to it because object-oriented programming and using classes, it is like the core of like a lot of coding. And I just kind of wanted to do a survey of it today. I haven't actually run this. Let me go ahead and run it. And so you can see that it says this is a constructor, this is a constructor, and then it prints it out, and it prints out the modified value, and then it prints out this is a method, and then it prints out, notice how this method only changed point 2, and it didn't modify point 1 at all. All right, that was your crash course into the Python syntax guide. You can leave this project however you'd like. You can leave it with them all uncommented, and you can run it, and it will be a giant output of variables and loops. Apparently one of my loops went out of control there. Kind of surprised it did that. Did I leave loops in kind of like a broken state? Oh well, doesn't really matter. The numbers 1 to 100 add up to this. Oh well, not going to worry about it now, but I was kind of surprised that my loop printed all those things because I thought that I left that over there. And try it just one more time. Oh, it's saying like give me a number in here. Okay, so I need to give it 0. My indefinite loop was still going. Yeah, so lots of things going on here. Not gonna go in and debug all this. So you can leave it with them all printed out. I think that might have blown up my brain a little. I'm gonna leave it with just classes, and then I can just go look at the code for everything else. Cool. I think that is a winner. I think that we can call it a day. So thank you for joining us. Tomorrow, we know the fundamentals of Python now. We're masters of Python. We're gonna start using graphics. Now graphics is fun because you can see things on the screen, but I will warn you now, you will have to be a little bit more patient, especially the first time you run a graphics program, because REPL's gonna have to like load a whole bunch of stuff, okay, and it'll be fine. All right, thanks for joining us. We'll see you tomorrow. Bye.